Okay, 1.15 limits at infinity and horizontal asymptotes. So let's look at a horizontal asymptote first. Okay, there's no graph here yet. This is just a random axis. Horizontal asymptote, we normally think of that dashed line that goes in a horizontal direction, but it is actually the behavior at the ends or the behaviors as x approaches positive and negative infinity. So if I were to graph this graph, the horizontal asymptote only applies as x approaches negative and positive infinity. So on the far right, it should be approaching that value, but in the middle, it can do whatever it wants. On the far left, it might be approaching the same value, or it might be approaching a different value, or it might only have the horizontal asymptote on as x approaches positive or negative infinity. So the horizontal asymptote y value exists as x approaches negative infinity or positive infinity. Okay, to find horizontal asymptotes, there's a shortcut that some of you learned in pre-calculus. You consider the fastest growing term in the numerator and denominator because you're plugging in x is approaching positive and negative infinity. You're going to simplify those initial terms, and then you're going to find the limit as x approaches positive and negative infinity. And that's going to give you the end behavior. Okay, let's look at the first one. It's y equals x squared plus 4 equals 3x squared plus x minus 5. Okay, if I were to plug in infinity or negative infinity, I would get infinity squared plus 4, 3 times infinity squared plus infinity minus 5. I'm going to get infinity over infinity. Because of that, we're going to only look at the initial pieces, not the initial pieces, the fastest growing terms or the highest degree terms. Okay, so I consider the fastest growing term in the numerator and denominator. I'm going to simplify just those pieces. So if I had x squared over 3x squared, what does that simplify to? That simplifies to 1/3. So as x is approaching infinity or negative infinity, the y is approaching 1/3. So there's a horizontal asymptote at y equals 1/3. Okay, let's try the next one. Okay, so for b, I have y equals x plus 4 over 3x squared plus x minus 5. Okay, let me first just consider if I were to plug in infinity or negative infinity. Okay, if I plug in infinity, I get infinity plus 4, 3 times infinity. I'm going to get infinity over infinity. If I plug in negative infinity, I'm going to get negative infinity plus 4, which is some kind of negative infinity. And the bottom, I get some sort of infinity. Since it's infinity over infinity or negative infinity over negative infinity, it is indeterminate. So I'm going to try to use the shortcut. So I'm going to look at the highest degree on the top and bottom, and then I'm going to simplify it. So x over 3x squared. Okay, if I simplify that, I get 1 over 3x. Okay, now let me consider this as x approaches infinity and negative infinity because I'm not sure how the positive negative affects it. Okay, now if I do 1 divided by infinity, what do I get? I get 0. Okay, let me plug in x approaches negative infinity. If I do 1 divided by 3 times negative infinity, that's 1 divided by negative infinity. I still get 0. Okay, so the horizontal asymptote is going to be at y equals 0. But there could have been 2 horizontal asymptotes, so I checked it in both directions. Okay, and then at the top, let's write a fun fact. Okay, if I do a number divided by infinity or negative infinity, I do get 0. Okay, let's look at C. If I plug in infinity, I get infinity squared plus 4, 3 times infinity. It's infinity over infinity, so it's indeterminate. I only do the shortcut if I get indeterminate. So let me look only at the leading term on the top and bottom. Highest degree, x squared over 3x. Let's simplify it. I get x over 3. Okay, let me consider what happens as x approaches infinity. As x approaches infinity, I get infinity divided by 3, which is just infinity. Okay, let's consider what happens as x approaches negative infinity. I get negative infinity divided by 3, which is still negative infinity. So there's no horizontal asymptotes. It actually has a slant asymptote if you learn that in pre-calculus, because as x approaches infinity, the graph's going this way, that way. Okay, so it's a slant asymptote, but there's no horizontal asymptotes. So let's also write at the top, if you do infinity divided by a number, you're going to get infinity, which implies no horizontal asymptote as x approaches infinity. Okay, let's look at a few more trickier ones, and I'm going to tell you some other stuff. Okay, D. If I plug in infinity, infinity squared at the top, infinity, infinity, infinity at the bottom. Okay, so I only want to consider the highest degree at the top and bottom. Okay, now this is not distributed out, so I'm going to imagine I distribute it out. So if I do 4x plus 5 times 4x plus 5, I'm going to get 16x squared plus a bunch of stuff after it, but the leading term is going to be the 16x squared. Okay, at the bottom, if I distribute this, I get x times x is x squared. I get minus 2x plus 5x minus 10. The highest degree is the x squared. Okay, if I simplify this, what do I get? I get 16. So y equals 16. Okay, E, y equals the square root of 4x squared plus x minus 2 over 3x minus 1. Okay, if I plug in infinity here, I get 4 times infinity. I square root it, it's still infinity. 3 times infinity is infinity. So this is infinity over infinity. Okay, now let's consider the highest degree on top and bottom. Okay, it's this 4x squared, but I'm going to square root the 4x squared. Okay, on the bottom, the highest degree is the 3x. Okay, now if I square root 4x squared, the square root of 4 is 2. The square root of x squared is, I want to say it's x, but it's actually the absolute value of x. Because when you square root something, you always get a positive out. Okay, now we're going to be careful on this one because it seems like it's going to be 2/3, but that absolute value is making me question whether it will be a positive or a negative. So let's consider both situations. Okay, if I plug in positive infinity, this is going to be positive. This will be positive, so they will cancel off. And I'm going to get y equals 2/3. As x approaches negative infinity, when we absolute value it, we get a positive. But this is going to be a negative. So when I cancel them out, I'm going to get a negative. So on the left, the horizontal asymptote is y equals negative 2/3. So this graph has two horizontal asymptotes. One is respected on the right and one is respected on the left. Okay, one more. Okay, same. I have infinity over infinity. So consider the highest degree. So I'm going to do the square root of 9x to the fourth over 5x to the second. If I square root 9, I get 3. If I square root x to the fourth, I get x to the second. Do I need absolute value? No, I don't need absolute value because x squared is always positive because it's squared. Okay, so the 5x squared goes here, and then I can cancel out the x squareds because they're both positive, so their signs aren't going to fluctuate depending on positive or negative infinity. So there's one horizontal asymptote, and it is at y equals 3/5. Okay, now let's consider some other infinite limits, and then I'll tell you why we need to consider some other facts. Okay, find the limit. This isn't a horizontal asymptote, this is just an infinite limit. So first thing is you just try to plug in infinity and see what happens. If I plug in infinity, I get e to the infinity plus 2 times, I get an infinity at the top. Infinity to the 10th is also infinity. Okay, if I do e to the x over x to the 10th, it's going to stay infinity over infinity, so I need a way to determine what the answer is going to be. Okay, I'm going to go back to the top and make some notes. Okay, we already know that a number divided by infinity is 0, and infinity divided by a number is infinity, but I need to figure out some infinities divided by infinities, and it depends on how fast growing each of the infinities are. So for example, if I have x and I plug infinity, I get infinity, but if I have x squared, that seems like it's going to be a bigger infinity. It's going to grow faster, it has a greater slope. Okay, if I do like x to 100, that's going to grow even faster. Okay, what could grow faster than x to 100? If the x is in the exponent. So if I do 2 to the x, that's faster growing than x to the 100th or 1000th or millionth. If I change the base, I can make it this even bigger, e to the x. If I go higher than e, maybe like 8 to the x, changing the base is going to make it faster growing. So on this list, as x approaches infinity, This is the fastest growing. This is the slowest growing, which means as x approaches infinity, kind of the bigger infinity takes its place. Now, what's lower than x? Like square root of x would be smaller. Maybe ln of x. Okay, now let's go back and consider. Okay, so if I only look at the fastest growing on the top and the bottom, I am looking at the e to the x and the x to the 10th. Okay, now if I plug in infinity, I'm going to get infinity over infinity. The question is, which infinity grows faster, the top or the bottom? The top grows faster because on this list, e to the x is very fast growing. So if I have a really big infinity divided by a smaller infinity, my answer is going to end up being infinity because the infinity on the top is going to grow at a much faster rate. Okay, now let's consider b because it's similar. Okay, I have infinity over infinity again. So if I look at the leading term here, I want to think about which one's faster growing. Okay, according to the list, 2 to the x is a much bigger infinity or faster growing infinity than the one at the top. So it's going to be like a little infinity divided by a big infinity, which is like a number divided by infinity. This is going to go to 0. If your infinity is bigger at the bottom, it's 0. If it's bigger at the top, it's infinity. Okay, let's consider the rest of these. And a lot of these, there's not really work to show. You have to think, which is hard. Okay, now if I plug in infinity here, let's think about this one. What do I get? Negative 4e. If I plug in infinity here, I get 1 divided by infinity, which is approaching 0. So negative 4 e to the 0 is negative 4 times 1, which is just negative 4. Okay, limit as x approaches infinity of 5e to the negative x. Let's rewrite this as a fraction, so it's without that negative, because the negative is making it unclear. So this is 5 over e to the x. Okay, now if I plug in infinity here, I know I'm going to have a number divided by infinity, which means 0. Okay, and again, not much work to show. You just have to think about it while you're doing it. Okay, now e, the limit as x approaches negative infinity of sine x over x. Now the sine of negative infinity, I have no idea what the sine of negative infinity is because sine is fluctuating. It goes up and down like a wave. The y value of sine is now somewhere between negative 1 and 1. So I know that this is going to be between negative 1 and 1. And if I divide that by negative infinity, if I do negative 1 divided by negative infinity, what do I get? I get 0 because it's a number divided by infinity. If I do 0 divided by infinity, I get 0. If I do 1 divided by infinity, I get 0. So sine is fluctuating or oscillating, but no matter what, when I divide by infinity, it's going to go down to 0 because the highest it will go is 1, the lowest it'll go is negative 1. Okay, let's keep trying. Okay, now what happens if I plug in infinity here? 1 divided by infinity is going to give me 0. So this is just saying, what's negative 3 cosine 0? What is the cosine of 0? Okay, g, the limit as x approaches infinity of sine of x. Well, I know sine is between negative 1 and 1. Do I know what it's going to be exactly at infinity? No, because infinity is not a real number. This does not exist. If it asks you the reason why, it's because it's oscillating. We do know it will be between negative 1 and 1, including negative 1 and 1. We just don't know what the actual value is going to be because it's going to go up and down and up and down. Okay, the limit as x approaches infinity of 5 times infinity cosine infinity. Okay, let's think about this. Okay, I know the cosine of infinity. I don't know what it's going to be. It is between negative 1 and 1. If I do 5 times infinity, and then I times it by something between negative 1 and 1, well, it might be negative infinity. It might be positive infinity. It might be 0 if it's between negative 1 and 1. So this one doesn't exist. There's no clear answer. It's going to oscillate.